All right, guys, this is the second part of the first semester exam review. Um, these are no calculator problems, or at least this first one is. So I'm going to give myself a little bit more room. I would suggest you do these on a separate sheet of paper. Okay, so take a look at this first one. Let f be the function that is given by this. This is a bit hard to see, but that does say ax plus b over x squared minus c. Can't get this. There we go. And so, I don't know why I'm stuck in eraser mode. Sorry. Hold on. There we go. Okay, so we have three statements here. The graph of y is symmetric with respect to the y-axis. That means f is an even function. That means like if I plug in x, I get a y value. If I plug in negative x, I get a y value. Or in other words, f of negative x equals f of x. The limit as x approaches 2 from the right of f of x equals positive infinity. So that tells me that on the graph at 2, the graph is going up to infinity. That means there's a vertical asymptote at x equals 2. And f prime of 1 equals negative 2. So the slope at 1 is negative 2. Okay, so part A, determine the values of A, B, and C. Hint, use the properties in the order given. So let's start with this. So f of x should equal f of negative x. Doesn't matter what order you write that in. So let's plug in negative x here. So a times negative x is negative ax plus b. If you plug negative x into x squared, you still get x squared minus c. And that should equal the original ax plus b over x squared minus c. Now, if I multiply the x squared minus c's away, I get negative ax plus b equals ax plus b. If I subtract b, those cancel. So negative ax equals ax. I can, subtract or add. I guess it doesn't matter. Let's add ax to this side. So ax plus ax is 2ax. Solve for x by dividing by 2a. So this tells me x equals 0. If x equals 0, I'm sorry, not trying to solve for, Bring me back here. Not trying to solve for x, I'm trying to solve for a. So sorry, let me go back here. Back to 2a times x. So this is true if a is equal to 0, right? We can divide by 2x. Okay, so a is 0. What do we know now? Let's update our f of x. So now we know f of x is equal to, instead of ax plus b, it's really just 0x plus b. So b over x squared minus c. Let's take the step number 2. So the limit as x approaches 2 is equal to infinity. So we're trying to solve for what would give me a vertical asymptote. So we need x squared minus c to equal 0. And we need the solution to that to be x equals 2. So I believe if we make c equal to 4, right? 2 squared is 4 minus c equals 0, then c equals 4. All right, so let's update our function once more. So now we know f of x is equal to b over x squared minus 4. I haven't quite forced that we would get positive infinity as we approach 2 on the right, but I think that's going to come out when we figure out what b is. And then f prime of 1 is equal to negative 2. So let's find f prime of x. So remember, b is a constant. So we could also do this, x squared minus 4 to the negative 1, because I would rather do power rule and a bit of chain than quotient rule. So f prime of x is equal to negative b times x squared minus 4 to the negative 2 times the derivative of x squared minus 4. So f prime of 1 is supposed to equal negative 2. So that means negative 2 equals negative b times 2 times 1. I'm going to put this in the denominator over 1 squared minus 4. So negative 3 squared. So negative 2 equals negative 2b over 9. So let's multiply by 9 over negative 2. So I'm getting that b is equal to 9. So determine the values of a, b, and c. Okay. And so just as a final note, now we know what f of x is. It's equal to 9 b over x squared minus 4. So 9 over x squared minus 4. So there's f of x. Okay, what about part B? Write an equation for each vertical and each horizontal asymptote of f. So now that we know f of x is equal to 9 over x squared minus 4, it means that we have a vertical asymptote at x equals plus or minus 2. And there's a horizontal asymptote, this is bottom heavy, at y equals 0. And it just asks for the equations. I don't even need limit notation or anything. So yeah, I think we can just go with that. All right, and then part C says sketch the graph of f in the xy plane provided below. So this is unusual. I have a feeling this question is a bit old. We don't often have to sketch these graphs, but we can go ahead and do that. So I didn't give you a plane. So do your own x and y axis, horizontal asymptote at 0, vertical at negative 2, positive 2. All right, and let's get some points on this. So there are no x-intercepts. The y-intercept, f of 0, would be 9 over negative 4, which is negative 2 and 1/4, right? So about down here. And because there are no x-intercepts, since there's no x in the numerator, f of x is never equal to 0. I know this opens down. We were told that the limit as x approaches 2 from the right is infinity, so I know this branch is up here. I'm not really going to plot any points on it. I could pick f of 3 and see what it comes out to. And then what about this other one? Well, I do know that we have y-axis symmetry, so again, I can get away without plugging in any extra points, but I could plug in f of plus or minus 3 and see what this comes out to. I guess it'd be 9 over 5, right? But that's not required. So this is my sketch of f of x. All right, let's take a look at the next problem. So number 2, I believe this would be no calculator as well. So let's put that down here. All right, so consider the curve defined by this, which is not something I can easily isolate a y for and get a nice function of x. So show that dy dx equals this. So we are meant to do implicit differentiation. So take the derivative with respect to x of both sides. And don't forget about product rule. There's almost always a product rule hidden in here. All right, so the derivative of 2y cubed is 6y squared. And remember, this is with respect to x. So we should have a chain rule dy dx every time we take the derivative of something in terms of y. This needs a product rule right here. I'm calling 6x squared my first function and y my second function. So plus first times derivative of the second plus second times derivative of the first. This is 12x. You can switch the order of those terms if you want. They're both addition. The derivative of minus 12x squared is minus 24x. The derivative of 6y is 6 dy dx. On the other side, the derivative of a constant is 0. Okay, so I am going to factor out my dy dx. That gives me 6y squared plus 6x squared plus 6. I'm going to move all of my non-x's to the other side. That's just these two terms. So I'm going to add 24x and subtract 12xy. And then I'm going to divide by the parentheses. Remember, you're showing that this is true, so you don't want to do too many steps at once. You know what you're supposed to get it as, so make sure you have things in the right order. I'm going to switch these two terms. I'm also going to factor a 6 out of the top and the bottom. So if I factor a 6 out of the top, that's where they're getting 4x minus 2xy. If I factor a 6 out of the bottom and correct the order of the terms, x squared plus y squared plus 1. And so I'm just going to do a final line here where my final step is exactly what they want me to write. So if I didn't correct the order back here, I would do it for my final. I'm not sure if that matters or not. But if they tell you to show that dy dx is equal to something, write it down exactly as they ask you to show. Part B, write an equation for each horizontal tangent line to the curve. So horizontal tangents occur when dy dx is equal to 0. So go back to their dy dx in case you miswrote it down here and set this equal to 0. This is true when the top is equal to 0 and not the bottom. Although the bottom is never equal to 0, x squared plus y squared is positive, plus 1 is positive. So you never have to worry about like if x equals 0 gave me the top equals 0 and the bottom equals 0, I'd have to throw it out. We don't often see that, though, for these problems. Okay, so 4x minus 2xy equals 0. Let's factor a little bit. We can take a 2x out. That would leave me with 2 minus y. So dy dx equals 0 when x equals 0 and when y equals 2. Now, we want the equations for the horizontal tangent line. So y equals 2 is a horizontal tangent equation. X equals 0 is not. We need to see what the equation comes out to. So remember, we have the original curve. So plug 0 into that for x and see what you're left with. 2y to the third. This term becomes 0. This term becomes 0. Plus 6y equals 1. This is not easily factorable, but if it's on a non-calculator part, it's going to be something small that we can plug in. I know it's got to be negative to somehow reduce this down to 1. And I don't know, let's see. If I plug in do we think it's like negative 1/2 maybe? I'm just going to try y equals negative 1/2. So that'd be 2 times negative 1/8 plus 6 times negative 1/2, so minus 3. Does that equal 1? No, it does not. Negative 1/4 minus 3, not equal to 1. So let's see. Maybe it is positive, but it needs to be something smaller than that. Or maybe it's not a nice number. Let's see. Our possibilities are, yeah, you know what? The possible rational zeros, there's this theorem that says the possible rational zeros are combinations of this factor divided by this factor. So my only options are plus or minus 1, plus or minus 1/2. 1 or negative 1 are certainly not going to do it. And negative 1/2 didn't work, neither will positive 1/2. So there are no rational zeros. So I suppose I will need to use Desmos for this. So maybe this is a calculator problem. All right, so let me see. Do I have Desmos open? I do. All right, so we're trying to solve when is 2. I'm not sure if I can use y. Let's see. No, yeah, let's use x. 2x to the third plus 6x. You can either say when is that equal to 1 or when is that equal to 0. Yeah, so that's definitely not a rational number. Okay, so y is equal to 0.165. We can round that to 3 places. That would be our other horizontal asymptote. All right. Excuse me. And then part C, the line through the origin with a slope -1. So dy dx at 0, 0 equals -1 is tangent to the curve at point P. Find the x and y coordinates of P. All right, so the line through the origin 0, 0. Oh, wait, it's not tangent at 0, 0. Sorry, it's tangent at point P. I was going to say, if I plug 0, 0 into this, I don't get -1. Okay, so we want to figure out the xy coordinates when dy dx is set equal to -1. So we want dy dx at point P, whatever that is, to equal -1. So let's plug in, or let's set that equation up. So 4x minus 2y over x squared plus y squared plus 1 is supposed to equal -1. So let's start working on this. So 4x minus 2y equals -x squared minus y squared minus 1. Honestly, though, if we're allowed to use a calculator, I would just be plugging this in here, right? Right? Like, I would just be saying, let's see what happens. I'm still learning about Desmos, so let's just see what happens. X squared plus y squared plus 1. Oh, it doesn't really like that, does it? Okay, fine. So let's see if it can do this. 4x minus 2y equals -x squared minus y squared minus 1. Well, what did that do for me? It graphed something strange. Is this something? No. Huh. Okay, so maybe I just needed to finish my... Sorry, you're on this Explore Desmos journey with me here. So x squared plus y squared, I can't remember if I just did this, plus 1 equals -1. Yeah, that didn't help me, did it? Okay, so I guess we do need to, even though we can use a calculator, I guess we do need to go ahead and solve this algebraically. So let's see. So this is not going to solve nicely. Like if I try to get all my terms on the same side, I think I would have to do some sort of fun, like complete the square type stuff if I wanted to solve algebraically. But why did they tell you that there's a line through the origin? There's this tangent line that goes through the origin 0, 0, and it has a slope of -1. That equation for that line is y equals -x. I think that's the key to solving this without trying to do complete the square type nonsense. So let's go back here. If y equals -x, excuse me, I can replace every y with a -x. So 4x minus 2 times -x, so plus 2x, equals -x squared minus -x squared, so it's still x squared, minus 1. This helps, doesn't it? 6x equals -2x squared minus 1. 2x squared plus 6x plus 1 equals 0. Oh, wait, not back into my, not back into my dy dx. Let's put it into our original equation. There we go. So let's see. That was 2y to the third. So 2 times -x to the third plus 6x squared times y minus 12x squared plus 6 times y equals 1. So this is negative 2x to the third minus 6x to the third minus 12x squared minus 6x equals 1. This is negative 8x to the third minus 12x squared minus 6x minus 1 equals 0. I cannot factor by grouping, but this does give me something I can put into Desmos that's actually helpful. So let's look for the zeros. When does that equal 0? Oh, at negative 1/2. Okay, that's my value for x. So x equals negative 1/2. And remember, y is equal to negative x. So y equals positive 1/2. So point P is negative 1/2, positive 1/2. So I started to go down the wrong path, but I kind of went back to like, wait, I'm getting stuck here and I can't solve something. I wonder if, I'm not going to take the time in this video, but I wonder if I can type this in. I assume I'd be able to get some sort of, see what the curve is there. So I'm not sure if this is calculator, honestly, or non-calculator, but I think it would need to be calculator to do this part B. All right, let's see. I think I have time for one more question, maybe. Let's see. So for question number 3, let me get it pasted into a different page here. Put it down here. All right, this looks like related rates to me. Anytime we're dealing with cylinders and whatnot. I'm going to treat this as non-calculator until I get stuck otherwise. So a balloon is in the shape of a cylinder with two hemispherical ends of the same radius of that cylinder. So like these two ends form a sphere. The balloon is being inflated at a rate of 261 pi cubic centimeters per minute. Let's start listing out some stuff that we know that we're given. That was a dV dt because it was cubic something per time. So dV dt is 261 pi, and I know that it's positive because we're inflating, cubic centimeters per minute. At the instant the radius of the cylinder is 3 centimeters, the volume is 144 pi cubic centimeters. And the radius of the cylinder is increasing at 2 centimeters per minute. So we know that R equals 3 centimeters when V equals 144 pi cubic centimeters. And we also know that at that instant, dr dt is increasing, so positive, 2 centimeters per minute. So we know a lot of stuff. At this instant, what is the height of the cylinder? All right, so volume of a cylinder, by the way, volume of a cylinder is pi r squared. Yeah, which is changing. So it's pi r squared times the height of the cylinder. And r is not fixed because this balloon is expanding both sideways and vertically. R is not fixed, and neither is h. So we need to start with our formula. So they want me to find, I have what I know. They want me to find at this instant what is the height. So they want me to find h if I know that r is 3 and v is this. So the first part has nothing to do with dH/dt or anything. So find h. All right, so 144 pi equals pi times r squared times h. Plus, oh, don't forget, we're adding the spheres too. Volume of a sphere is 4/3 pi r cubed. And if I put these two spheres together, they form these two half spheres, they form one full sphere. So plus 4 pi over 3 times r to the third. 3 to the third is 27. All right, so, and this is actually 36 pi, right? 27 over 3 is 9. 9 times 4 is 36 pi. So to solve for h, let's subtract 36. So that's what? 108 pi equals 9 pi h. So h is 108 pi divided by 9 pi. The pi's cancel. Let's see, does 108 go into, does 9 go into 108? It goes into 10 once, 12. So yeah, 12 centimeters is h. Part B, at this instant, how fast is the height increasing? So now it is find dh dt, and we know all this other stuff. So we're going to use that same volume formula. So volume is pi r squared h plus 4 thirds pi r cubed. We have to d dt both sides. Now remember, you need product rule right here because you have two different variables. This is just power rule. So this just becomes dv dt. Product rule on this is first times derivative of the second plus second times derivative of the first. Remember that r needs a dr dt as well. Chain rule on both of those. Plus the derivative of this. So 4 thirds pi times 3 will be 4 pi r squared times dr dt. That was power rule and then chain rule. Now we can plug in what we know. We know all this stuff. Do we know dv dt? Yeah, dv dt is constant, so it's 261 pi equals pi times r squared, so 9 pi. Don't know dh dt, that's our unknown. Plus we do know the height is 12, so 12 times 2 pi 3 times 6 pi times dr dt, which is 2, plus 4 pi times 3 squared times dr dt, which is 2. Oh my gosh, okay. We probably, again, I don't know if this is calculator or not. I don't know. Oh, I do know that we don't have to simplify this very much, but I'm just going to. So this is 12 times 12. So this is 144 pi. This is 8 times 9, which is 72 pi. Those added together be 216 pi. Have I done my math right? I think so. So if I subtract 216 pi from 261 pi, what do I get? I get 45 pi, and that equals 9 pi times dh dt. That worked out nicely, right? And then we divide by 9 pi, we get 5. And what is height measured in? It's a linear measurement, so centimeters. We're talking about per minute. dH/dt. It makes sense that it's positive because this balloon is being inflated, so the height is increasing. All right, I'm going to stop this video here, and then that will bring us to the second page of the packet for the next video.